Hello, we are Diana, Jorge, and me, and we are going to talk about the Earth's dynamics. First of all, I'm going to talk about Wagner's theory. He said that at first all the continents were only one called Pangaea, but 2 million years later, Pangaea broke and the continents moved very slowly to the positions they are today. Some of the evidences of this theory are that he realized that the coastlines of Africa and South America fit together, but we can see this also in North America and Europe, and these evidences repeated. If we talk about the structure of the Earth in the geochemical model, the Earth is divided in three main parts that are the core, the mantle, and the crust. The core that can be inner or outer. The inner one is in the center of the Earth. It's solid, made up of iron and nickel, and it's the hottest part of the Earth. The outer core surrounds the inner one. It it's have high temperature, it's liquid and made up of iron and nickel. The second part is the mantle, that is the thickest layer and is made up of semi-molten rock called magma. In the upper part of the mantle, the rock is hard, but in the lowest starts to melt. Finally, we have the crust, that is the outer layer and it's made up of solid rock. And we have the geodynamic model that is divided in six parts. First, we have the troposphere, that is the closest layer to the surface of the Earth. Here, we can find the air we breathe and the clouds. Secondly, we have the stratosphere, it has its own set of layers that contains the ozone layer. It absorbs also the solar ultraviolet radiations. Then we have the mesosphere. The air is thin, so you wouldn't be able to breathe up here in the mesosphere. In the layers above the mesosphere, there is not enough air for them to burn, so when they enter to the mesosphere, they burn immediately. Then we have the ionosphere, that we can't see here in this picture. It's called like that because in this layer gases are turned into ions by solar radiation, so they have electrical charge. When charged particles are affected by the magnetic fields of the Earth and the Sun, the auroras appear. Here we have an example of auroras. Then we have the thermosphere, that is the layer that doesn't have gas molecules in order to transfer all the heat to a body. This also applies to the waves of sounds. It's thicker than the previous ones, and the International Space Station is located here. Finally, we have the exosphere, that is the last layer. Also separates the rest of the atmosphere from the outer space. It's almost as white as the Earth. It's very cold and there is no air to.
I'm going to talk about the theory of tectonic plates. This theory says that the Earth's outer shell is divided in different parts called plate tectonics. This helps to know how the continents move. Some scientists think that move because of the ridges, which are formed when magma goes out, creating a new seafloor. As the seafloor extends over the magma that had already explained before, the continents are transported by the sea. The boundaries are narrow zones between plates where most of the movement occurs. There are three types of boundaries. The first one is the divergent, is when the plates are blurred away and a new crust is formed. The second one is the convergent, that occurs when one plate slides over another and crust is destroyed. And the last one is the transform boundary, that occurs when plates slide horizontally and crust is not destroyed and is not created. In the world, there are different types of plates. One is the oceanic plate, that occurs in the Pacific, in the Nazca, in the Scotia, in the Philippines, in the Cocos, in the Antarctic, and in the Juan de Fuca plates. And the other type is the continental plate, that occurs in the Eurasian, in the North American, in the South American, in the Australian, in the African, and in the Caribbean plates. A clear example of divergent plates are the North American plate and the Eurasian one that are pulled away and create new crust. An example of convergent plate are the Nazca plate and the South American one that slides over another and crust is destroyed. The Eurasian plate and the African one are an example of transform plate.
Okay, now we are going to talk about volcanoes. and its distribution in the Earth. So there are quite a lot of volcanoes in the Earth, but the zones that have the largest amount of volcanoes are in the Atlantic Ocean, here in Africa, maybe here in Italy, all this zone, and here is surrounding the Pacific Ocean and the Pacific Plate, that is called the Ring of Fire. It's where the largest amount of volcanoes is. So here we can have a better look to the Ring of Fire because the perspective of the map is different, so it's easier to see. Okay, so now we are going to see the distribution of earthquakes, that you can realize that the little spots that represent earthquakes form the shape of the plate boundaries. This is the African plate, and it's the shape that the earthquakes have created is very similar to the real one. And here the Pacific plate, and in the boundaries of the Indo-Australian plate are the same as the boundaries of the real plate. And here the Nazca plate is very similar too. Well, in the Eurasian plate there are some earthquakes too. So, last of all, we are going to talk about mountain ranges and how they are formed. So they are formed by with continental and oceanic plates. The continental plate slides over the oceanic plate, while the oceanic goes, well, the plate goes down. In what is called, this is called the subduction zone, and well, so the process is called subduction. The angle that the subduction zone has determines the the shape of the mountain ranges, the location of the mountain ranges, and the formation, how they are formed. You know that the mountain ranges are a lot of mountains in the same place. So, well, that's all. Uh, uh, this is the end of our presentation. We hope you liked it, and thanks for watching.